our last podcast here is going to do double duty. We are going to talk about kind of a special case of a double replacement reaction, which is called an acid-base reaction. And then we're going to do our last reaction, which is a combustion reaction. Neither one of these should take a whole lot of time. Okay? So the first thing we're going to do is talk about a special case of a double replacement reaction. And this special type of double replacement reaction is called an acid-base reaction. And it's really no different than a double replacement reaction, but one of the things that happens in this particular reaction is you always get the same two products. Okay? Whenever I take an acid plus a base, I get a salt of some type, which, if you remember, a salt is an ionically bonded substance. And you get water. Okay? And water is actually the substance that's actually produced, because the salt is actually going to remain in the dissolved solution. Now, just to talk about a base, because we have never been real specific with what a base is. Okay, a base is anything with hydroxide ions, and that's kind of the definition we're going to stick with for right now. Okay, when we do the chapter on acids and bases, that will change. An acid, remember, is anything that has the hydrogen ion with it. We've talked about those. So here we go. Okay, this is really just a double replacement reaction. I have sodium hydroxide, which is my base, plus hydrochloric acid, HCl, which is my acid. And really, this is a double replacement reaction. The Na goes over and it replaces the H. So there's my salt. My salt is NaCl. The hydrogen there goes and replaces the Na, and you get HOH. But that HOH we would never write like that. It's H2O, okay, because it's water. But we get HOH out of it. So we get H2O. Okay, now, this is a double replacement reaction. So one of the things is, one of these is aqueous. And here's our group 1 element again. So this is actually aqueous, but there's also no precipitate, because water is not a precipitate, but water actually comes out as a liquid. And so water is what is actually produced in this type of reaction. Okay, so let's just do a couple more of these. I have chromium hydroxide, chromium 3 hydroxide to be exact, plus nitrous acid. And again, it's a double replacement. Chromium kicks out the hydrogen. Okay, and so I get Cr, NO3, NO2, 3. Hydrogen kicks out that, and I get H2O. Now, this one, we would actually need to go back and balance a little bit. I'm not going to spend time doing that. You should always balance equations, and we're not balanced right now. Okay? But again, this chromium 3 would be aqueous. This water would be liquid water. One last one. Go ahead and complete this one. And so the products of this one are going to be FeSO4 plus H2O. Okay? And so those are our products of an acid-base reaction. You always get a salt, and every one of these, because it's an ionically bonded substances, those are your salts, and then you get the water. Okay? And that's all I'm going to do with those. So that's just one of our special types of double replacement reactions. Now we're going to go on to our fifth and final type of reaction. Our fifth and final type of reaction is called a combustion reaction. Okay? Now, a combustion reaction is basically burning something. Okay? And when you burn something, the element that you always have to have is oxygen. Okay, so in this combustion reaction, we're going to have a substance called a hydrocarbon. A hydrocarbon contains hydrogen and carbon, hence the name hydrocarbon. And we're going to always react that with oxygen. And what happens is you always get the same products, carbon dioxide and water, every single time. Okay, with a combustion reaction, we are going to assume that we always get carbon dioxide and water. Okay? So, here is a simple hydrocarbon. It's methane. And that hydrocarbon, methane plus oxygen. Okay? What we're going to get as products, carbon dioxide and water. Those are our products. Okay, another example. Propane. Well, where do you have propane at? And propane is what is used in all gas grills. So if you have a gas grill, what you're doing is you're burning propane. Okay, so I have propane plus O2. That's going to give me carbon dioxide and water. Those are my products. Okay, another one. C4H10. C4H10, this is actually called butane. Where do you have butane at? Okay. Butane is the gas that's used in lighters. Okay? And so butane plus oxygen will give you CO2 plus H2O. Okay? Now, C4H or C8H18. Okay, this will be my last one. Okay, this is octane. Okay, where do you use octane? Every time you drive your car, you use octane. Okay, as 16-year-olds getting your license, when you go and you fill up your car with gas, you are filling your car up with octane. In order for your car to run, you need to react that octane with oxygen, but the products you get are CO2 plus H2O. Okay? Now, one of the things that happens, and they always talk about, is there is a process where you could get an incomplete burning of any one of these gases, and an incomplete burning of any hydrocarbon will actually produce carbon monoxide. And that's what you have to be careful about, because there's always some incomplete burning, and then you always get a little bit of carbon as well. Okay? But for all intents and purposes for us, okay, we are going to assume that we always get carbon dioxide and water. But just know that in the real world, this is what happens. Okay? Now, one last little thing. When we talk about hydrocarbons and burning, they could contain some other elements, mainly some oxygen. So this actually could be a hydrocarbon that could react with oxygen. But because we're burning it, okay, you get carbon dioxide and water. Okay, this would be another compound. This is actually methanol. And this is actually ethanol. And ethanol is actually a substance added to your gasoline. Okay, so it's obviously something that we want to be able to burn. If you use E85 as the gas, you're burning 85% ethanol. Okay, so it is something that will burn, but you still get carbon dioxide and water. And what happens is it's actually a more complete burning, so you do get more carbon dioxide and water out of these two things. But just be aware that you don't have to have just a hydrocarbon, okay? And actually these are kind of classified as hydrocarbons anyway, but they have another element in them. So that would be it. Okay, oops, you don't need that. That would be it as far as your 5 types of reactions. Okay, so we should be good to go and you should be able to complete the last worksheet, complete the last lab, and do the review sheet.